Day18 of the data science challenge, we'll be going over index and query optimization. So we'll look at how indexes are used to boost query performance and the art of query optimization. These techniques are essential for making your SQL queries efficient and scalable. So we'll be going over understanding indexes, so types of indexes, how indexes work, creating and managing indexes, and query optimization techniques like analyzing query plans, avoiding common pitfalls, optimizing joins and subqueries, and then best practices for indexing, a hands-on challenge, and exercise in Day18 summary. So what are indexes? They're data structures that improve the speed of data retrieval. However, they come at a cost, increased storage, and slower write operations. Effective query optimization involves leveraging indexes and writing efficient queries. So in order to understand indexes, there's different types. So let's go over these types. So there's the primary index, which automatically is created on primary keys. A unique index, which ensures unique values in the index columns. Clustered index, which sorts and stores data rows in the table based on key values. Non-clustered index, which stores pointers to the actual data rows. Composite index, which indexes multiple columns. A full text index, which is optimized for text search. So it looks like there's lots of useful searches here. So how do indexes work? Indexes are like a book's table of contents. Instead of scanning the entire table, the database uses the index to find rows faster. So there's an example. Without index, you have select star, selects everything from the orders table where customer ID is 1, 2, 3, 4, 5. So it's giving a specific clause. With index, it's saying create index. Notice it's different than select. IDX underscore customer ID on, so it's putting it on this table, orders customer ID, and then select the star from orders where customer ID is. So I wonder how the output is different. We have creating and managing indexes. So you can create an index with this command, create index idx underscore column name on table name column name. Then you drop an index, you have drop index idx underscore column name. You can view existing index with PostgreSQL from doing select star from pg underscore indexes, where table name is equal to table name. And you have query optimization techniques. So you can analyze query plans, use the explain keyword to understand how the database executes a query. You can do explain select star from orders where order data is greater than this date. So I actually didn't know that explain is a keyword here. That seems pretty useful. And you can check for after that date in January 1st, 2024. So avoiding common pitfalls, you can avoid select, it's only specifically only on required columns. Index usage, you can ensure indexes are used for filtering and joining, and you can avoid functions on index columns. So you have a void here, it says select star from orders where year order date is 2024. Then you have use select star from orders where order date is greater than 2024 January and order date is less than 2025 January. And then you have optimizing joins and subqueries, which is basically using index columns in join conditions. You can avoid unnecessary subqueries used with CTEs or common table expressions, as we saw in the last video. And let's look at these examples here. So this one is saying it's an inefficient subquery. So you have select star from orders where customer ID is in this, select customer ID from customers where country is USA, and then you have optimized query with US customers as select customer ID from customers where the country is USA. So what is the differences? We have with here, the select is put afterwards, it's indented, and there's a subquery in this one, right? And this one's still going. So you have select star from orders, join US customers, and there's a join here. You can see on orders.customer ID is equal to US customers.customer ID. And then we have best practices for indexing. So index selectivity, index selectively, you have index columns frequently used in where, join, or order by clauses. Monitor index usage. So you have use, query, execution plans to ensure indexes are utilized. Avoid over-indexing. Too many indexes can degrade performance for insert, update, and delete operations. We also have regular maintenance, which is rebuilding or reorganizing fragmented indexes. So hands-on challenge, create a non-clustered index on the order date column of the orders table and measure query performance with and without the index. Use explain to analyze a query and identify optimization opportunities. Optimize a query using a composite index. So that seems pretty useful. I can try these things out. And they have some exercises listed here. So exercise level 1, create an index on the customer ID column of the orders table. Use explain to compare query plans for a query with and without an index. Write a query to find all orders placed in 2024 and optimize it using an index. We have exercise level 2, which says implement a composite index on customer ID and order date in the orders table. Write a query to retrieve orders for a specific customer within a data range. Use a query plan to analyze the performance of a complex join query and suggest optimizations. Then create and use a full text index to search for keywords in the comments column. So day 8 summary, basically we went over the importance of indexes and query optimization. By understanding different types of indexes and applying best practices, you can significantly improve query performance. In day 19, which is the next day, it will go over transactions and concurrency control. And thanks for listening. Feel free to reach out if you have any questions or you want to share progress. Bye for now.